In this lesson, we are going to introduce the idea of a vector and just kind of talk about it geometrically, not so much algebraically. So a vector that is an example of a vector, and it has magnitude, which is length, and it has direction. All right, so this could be turned in a whole lot of different directions, but that one specifically looks like that. So typically we'll draw a vector from the origin out in whatever direction, but actually this vector could start here, and as long as it goes in the exact same direction with the exact same magnitude, then that could also be a representation of vector u. A couple of the looks to it is if you take 1/2 of it, so if you start here and you take 1/2 of it, then that could be 1/2 u. And then if you go in the opposite direction, but the exact same direction, exact same length, then we just tack on a negative onto that. So that's negative u. Okay. So, so that's kind of the basic idea of it. It just has a direction and it has a length to it. So you can add vectors together. So the sum of vectors looks like if you're going to add vector A plus vector B, so we'll just kind of draw out what A looks like, we'll draw out what B looks like. So if A looks like that, and B looks like that, then if you want to add a vector A plus vector B, you're basically adding tip to tail. So you're going to tack one vector onto the other vector. So it's basically like taking this vector and just moving it over and tacking it onto this, or taking the vector A and tacking it on kind of tip to tail on that. So it's either going to look like this. So here's B kind of tacked onto A. So that would be A plus B. Or you could do it A being tacked onto B. It won't matter because it doesn't matter if it's A plus B or B plus A. But your vector that you get out of it, the sum of it, is actually this one. So that is the sum of A plus B, is that vector right there. So it's a combination of the two. So it does create this parallelogram, which will play a role and have some properties going on with that, and we'll be using that information to do some other word problem types of things. If you were going to take the same two vectors and do A minus B, so you're looking at, here's roughly A again, and then this is roughly B. If you take A minus B, it's really the same thing as A plus negative B is what you got. So negative B, like this is positive B, negative B would look like this. So that would be negative B, and that's what you would be tacking on, because you're really, again, tip to tail, so you're taking, now this one, we're going to go from A to B, and we're going to see if it matters if we go the other direction, that you're going to put that onto here. And then your vector that you get out of it is going to be this. So that one is A minus B. This one was negative B. So this is kind of your tip to tail. And blue is your vector you get out of it. So could you have taken, once you have negative B, and really if you turned it into an addition problem, then it really wouldn't matter, because you could take this piece, and if I did everything perfectly to scale, then I could just tack on A, and they'd end up in the exact same location. So blue is what that looks like if you add those two pieces together. All right, so that's just a very, very brief idea of what some of the visuals of adding and subtracting some of your vectors, and you might need to double them and subtract them and do all sorts of things. Well, you're just extending out the lengths, and then you're just kind of tacking vectors on from tips to tails kind of thing. So that is a little bit of geometrically defined vectors, and we'll do some word problems next.